My name is Jamia Stokes, and this is project number 3, homework 6.1, which is the basic concepts of fractions and rational numbers. So first we're going to start talking about fractions, and so our first example is going to be a rectangle. Okay, so we have 5 boxes on this rectangle, and 2 of them happen to be shaded. Okay, 2 are shaded. Okay, 2 of them are shaded. So we counted before and we had 5 boxes. So automatically it's going to be over 5. So we just have to count how many are shaded, and there are 2 shaded. So it's going to be 2 over 5 for the answer. And it's very, very important that you put the amount of boxes that there are on the bottom and the amount that are shaded on the top. Okay, so that's example number 1. And for example number 2, which is the same concept, fractions can be a little confusing, but as long as you take your time and you work them out, you count the correct number of boxes, then you should be fine every time. The second one, we're going to do a circle. So this is our circle, and this happens to have six spaces. So 1, 2, 3, 4, 5, 6. We have 6 of them. So we're going to shade 2. And it's not always going to be 2. These are just my examples. I'm going to do some more that have more than 2 that are shaded. So it's not always going to be 2. So don't look for that. So we have 6 spaces available in this circle, and there's only 2 shaded. So it's going to be 2 over 6. So when you're writing a fraction, you can write them either way. You can write them over like this, or you can write them like this. It's the same thing, means the same thing. It's just different ways of writing them. You can write them however you decide to. It's just completely up to you. Sometimes I write them like that. Sometimes I write them over on top of each other, or sometimes I just write them the second way I show you. So okay, this one is going to be more than 2 that are going to be shaded. So that's what I want to show y'all. So you don't always think it's going to be just 2 of them, because it's not. Okay, and this one is our box that we're working with today, right now, and this is example number 3. And I did say that this was homework 6.1, dealing with fractions. So homework 6.1, I did say that. Okay, so this is going to be 6 squares, 6 spaces available. So you have 1, 2, 3, 4, 5, 6. Okay, and so we're gonna shade a couple of them, and like I said, they don't always have to be 2 of them that are shaded. It can be more than 2. It could be all of them. So it could be it just depends on the question and the problem. So don't always look for 2, because it's not always going to be just 2. Okay, so this one we have 4, and they don't always have to be beside each other. They can be spaced out, so it still means the same thing. Don't always just look for the ones that are close together, because they're going to be different. They're not always going to be the same. So we already said that there were 6 of these squares, so you can write your little bar and put 6 on the bottom. Always remember to put the amount of squares on the bottom and the amount that are shaded on the top, usually because the amount that's on the bottom is the bigger number and the amount that is shaded is a smaller number. So usually you want to put the small on top of the big one, of the big number. So in this case, we have 1, 2, 3, 4 spots that are shaded, which is 4 over 6. And you do not have to reduce these or simplify. And what I mean by simplify is make them not be able to be divided into. So whatever is shaded, that's your answer. You don't have to worry about doing anything else to it. Okay, let's do some more of these. So fractions can be very tricky. They tend to be some people's like worst thing to do. Some people hate them, some people love them. They do get harder eventually. They're not always going to be these easy baby problems. They get harder and harder. But yeah. So don't always expect for them to be just these easy problems. Okay. So let's look at one more of those, and let's do a bigger one, and then we're going to move on to something different. So this one is going to be a little bit more spots in it. Okay, so this one is a little rectangle, not a rectangle, a diamond shape, as best as I can get it. So we're gonna count these squares. When you're counting them, make sure you go slow and take your time so you can really get an accurate count. So it's gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you have 11 spaces. So draw your equal sign, bar, 11. Okay. And so let's go ahead and shade like 2 of these. Okay. We have 2 spots that are shaded. So what is that? What is going to be our fraction for this example? You have 11 spaces and you have 2 of them that are shaded. So what is going to be the example? What is going to be the answer for this example? It's going to be 2. 2 over 11, because you only have 2 spots that are shaded. Now, if you have 4, it'll be 4. It'll be 4 over 11. And if you had 1, it'll be 1 over 11. And if you had all of them shaded, it'll be 11 over 11. So don't get mixed up with that. It's very simple. Just take your time and count them and make sure you have the right amount over the right amount. Okay, so let's look at another lesson really fast. I feel like that was a very simple lesson and I don't really need to spend too much time on it. So let's look at this word problem, and this problem is from lesson homework 5.2. And it's called addition and subtraction of integers. So yeah, and basically an integer is just a number, so don't let those big words fool you. It's just another way of saying number, integer. So the question is, one day the temperature dropped from 0 degrees Fahrenheit to negative 10 degrees Fahrenheit. How many degrees did it drop? Okay, I'll read one more time. One day the temperature dropped from 0 degrees Fahrenheit to negative 10 degrees Fahrenheit. How many degrees did it drop? And all you have to do is look at this problem and simply subtract. So let me write it down for you so I can show you visually. So the temperature dropped from 0 degrees Fahrenheit to negative 10 degrees Fahrenheit. Okay, and the F is Fahrenheit and the circle is mean degrees. So you simply just subtract these two. Okay, so 0 minus 10 is 10. And that is your answer. So it dropped 10 degrees. Okay. And you know, any question that you have like that, you would do the same thing. It's not just, you know, this problem. You will have, you might have the same problem, but it'll be a different number, obviously. So you would do the same thing, which is just subtract them, and you will have the same question, same setup, but just a different number, just different numbers. So you will have to remember that and remember to just subtract the two, and that was really simple. Okay, and let's go back to homework 6.1 really quickly before we run out of time today. And let's look at some fractions with different denominators. So our first one is going to be 9 over 20. And 15 over 22. Okay, and as you can see, they have different denominators, and as you know, denominator is going to be at the bottom and the top is going to be a numerator, but right now we're just looking at the bottom, which is the denominator. Okay, so you're going to multiply the denominators. 20 times 22, which gives you 440. Okay, you're going to multiply those for your first step. I'm going to draw number 1 beside it because that's what you do first. You multiply the 2. Okay, and then we're going to take 9 21st because it's the first fraction that we got first. So 920, okay, equals 922 over 20 times 22. Okay, and this is just simple multiplication. So put this in your calculator or whatever, and you get these answers right out. 198 over 440. All right, and then we're going to look at 1522, and what we're doing is we're trying to get the same denominator, and once we get the same denominator, it'll be equal. And this is all you're doing, is just basic multiplication. So you first want to start off by multiplying your denominators to get this number here, and you're going to multiply your top 9 times this 22, which will give you 198, and then you want to multiply 20 right here. That's where we got 20 from, 20 right here. And then you want to also multiply it by this number's denominator, and it will obviously give you 440, the same thing we got here. So that's how I got this one. That's how I got this answer. So let's do the same thing for 15 over 22. So you want to multiply this one by 20, and you're just cross multiplying well, not cross multiplying, but you're just taking, you see how we use this denominator for this one. So this time we're going to use this denominator for 15 over 22. So it's going to be 15 times 20, and then 22 times 20, Okay, 15 times 20 is 300. And then 22 times 20 is 440. And you see how we got the same denominator for both? That is what we want. We want the same denominator. It's easier, way easier to solve when you have the same denominator. Now we're not gonna solve these. This is just all that we're gonna start. This is where we're gonna stop at right here. That'll be for the next lesson. But right here, I just wanted to go over how to get the same denominator. So it'll be easier to solve next time once we move into that lesson. But yes, that's all I have for today. So I just want to do a recap. We went over 6.1, basic concepts of fractions and rational numbers, and then we hit a little bit of 5.2, addition and subtraction of integers, which is very simple lesson. Really nothing to it. That in 6.1 is very simple lesson. Really nothing to those. And then that was all we talked about today. So I hope that I made this as clear as possible for you, and you can be able to do this on your own with no problems. So yes, thank you for watching and have a great day.